Hi, this is Pablo Pasos, and this is our series of how to work with an OpenEHR clinical data repository step by step. We will try to test in this video how to work with EHRBASE and use the clinical models we created on the previous video. So for working with EHRBASE, you have many options. You can download the code and build it locally and run it locally, or you can use, for instance, the Docker images or the Docker Compose file. So I will use the Docker Compose file. This is the documentation. You can read that documentation here and replicate this installation and running. For this, just one note, if you are going to follow these steps, you might need to update your Python version before installing the Docker Compose. I had some problems installing the Docker Compose. So it's not a problem with the EHRBASE itself, but to have this prerequisite already on your machine, you might have some issues. I did these steps, and what I will do now is Docker Compose app that will start, hopefully. So I have everything here. I need to do sudo Docker Compose app, and that should start. So in my installation, the Docker Compose was installed in a Python dependency module, I guess, some kind of package Python uses. I'm not a Python developer or user, so let's check. So we should run this on my machine. This is what works. And this should run two things. This should run the EHRBASE and the database. If you get these errors, sometimes I get these errors, I believe there is some condition that the application server is trying to reach the database, but the database is not yet started. So sometimes you will get those exceptions. Let's try again. And now it seems to work. So those are the issues I found following these steps. And this should run the application server on port 8080. So you need to have that port open. And we'll run a Postgres database in the standard Postgres port that is 5432. So if we test that, net stats, we should have Postgres running on that port and the application server on 8080. Yeah. So this seems to be running okay. Then what we want to do, and we will do this with all the clinical data repositories we will test, is first we need to create an EHR or a couple of EHRs for testing. So this will be the EHR for a patient. So each EHR will have a different patient, and each patient will have just one EHR. On an EHR, we can add documents. So that will be the OpenEHR composition. And before we add documents, we need to upload the OPT, that is the operational template that we designed in the previous video, to the server. So we need to create EHRs, we will upload the operational template, we will generate, that's an extra step, some sample compositions, clinical documents, and then we will use the post-composition REST service to create a document inside an EHR. When we had that, and we do that for a couple of compositions, and we can also create documents for a couple of EHRs, we will run some queries, data queries, to retrieve that information back. So first, we will try to generate some documents based on the operational templates that we created on the previous video. For that, we will use the OpenEHR Toolkit. You can sign up here. There's a free account that you can use. And I already have an account here. I will use my personal account. So just the basics of the OpenEHR Toolkit. When using the toolkit, you can upload templates to your account. You can upload archetypes. You can generate compositions, and you can use the API. For now, it's just for templates and archetypes. We will create more services in the future to add access to the generated compositions and to generate compositions on the fly too. Yeah. If you go to templates, I already have a list of templates here. These are operational templates, OPTs. What you need to do is to go to upload here. We will choose the templates that we created on the previous video that are on this folder, step by step, clinical models, and we have demographics and we have data science monitoring. These demographics, we will upload that. The toolkit will validate the syntax of the operational template is correct. So you might get some errors depending on if you edited the file manually or depending on a specific template editor that you use that might not be compliant with OpenEHR or with a specific format. You might get some errors. This uploaded correctly. Internally, the OpenEHR Toolkit manages the versions for the templates and for the archetypes. So you can upload and update the same template several times, and you can just change the internal version using the semantic versioning format. When you upload one template here, you can use these services based on the template. So you can use this service to generate a JSON that is a composition, or a version that is a composition container with versioning information using the canonical JSON format. This is the JSON format defined by the OpenEHR standard. And there are JSON schemas that define that format. So this will have all the structure defined by the template will be a valid JSON document against the OpenEHR JSON schemas and will contain random data. Yeah. Then we have a canonical XML generator. It's the same, but following the XML format, the OpenEHR XML format. Also, OpenEHR has XML schemas available, and this format follows that. Then you can see the dependencies of this template. So let's click on that. And for this one, this was a simple template that we created using two archetypes. And if you remember, we have a composition archetype that references an admin entry, and that's all that we have for this one. So it's a very simple template, but in general, these templates are very complex and have different levels. Yeah, you might have 3 or 4 levels of archetypes referencing other archetypes, and also you might have at this top level a lot of archetypes. So you can have more archetypes here, and the tree could be deeper. Yeah, so this is more complex in general. It's a nice way to see all the archetypes referenced by your template. Yeah. Then this service allows you to access the archetype nodes. So you have here, if you remember, all the archetypes and templates are basically trees of definitions. It's a tree structure. So with this, you can actually see all the archetype IDs used inside this template, and you can see here all the paths to each node defined by each archetype, and each path is the path relative to the root defined by the corresponding archetype. So here you can see that the root for the composition is actually the composition itself. So it's just slash. Then you have in the composition a path for the attribute context, and context could have a setting, a location, and start time and end time. And you can see end time and start time are DV datetime, a location is string, and the setting is a coded text. For instance, you can see that. And here on this column, you can see the name of that node for each language. If we access this information from a template, you will see just one language here, because these templates allow you to put just one language, one translation, I would say. But the archetypes themselves could contain many languages. So each node, the name and description of each internal node of each archetype could be translated to many languages, and those languages could be inside the archetype. But the template has just one language. Yeah, so that is why we have just one language here, one name for each node. Yeah, and you can see these nodes that were added here, these null flavors. This is following the OpenEHR model, where you can put information about missing information. So when you don't have a value for the sex or for the date of birth, you can add a value to the date of birth null flavor or the sex null flavor, and that will say, we don't have, for instance, the data available at this point in time for the sex. So you can put this information here in the null flavor, and it's a coded text. Or you can say the patient refused to give us this information, or the patient is unconscious and can't give us this information. So you can put these reasons to have this value empty in this null flavor attribute. So that is always there. And this is looking at the internals of the archetypes. Yeah. And one extra comment here. These paths are very important because we will use these paths to query data. So when we are querying in an OpenEHR data repository, we will use this as an identifier of the data point that we want to retrieve from the server. For instance, if we want to retrieve the sex information for a patient or for a list of patients, we will use this archetype ID as the identifier of the general concept that will be demographic data in this case, and this specific path to retrieve the information to pick the data point about the sex, or this other path to pick the information about the date of birth. And that is how every clinical data repository that is compliant with OpenEHR works. So this view is very important because this is something that we will use a lot in data queries. And there is another view for the internals of the template, that is the template nodes. And this is very similar to the archetype nodes, but the paths are different. If we check that, you can see that we have the template ID is demographics, and here you can see this path points to the root of the admin entry. And this path is absolute from the root of the template. So inside a template you can have many archetypes, and these paths you can see that actually include or could include an archetype ID. So basically it's saying inside my template I have a reference to an archetype, and then inside that archetype I have a path to a certain node, and this is saying that this is the root of the template, this is one of the archetypes that you have defined in the template, and these paths are relative to the root of this archetype ID. And this is a valid archetype path. You can see from here, from the slash, this is a valid archetype path. And you can see that these paths actually point to the same things that the archetype paths point to, just considering the root of the template instead of the root of the archetype. So you have a coded text for the sex, a date time for the date of birth. And if we have constraints defined, we can switch here, the switch for constraints, and you can see, for instance, the sex node that is a coded text internally in the template is constrained by a list of codes that are local codes. This means that the codes are defined in the archetype itself, and this is the list of possible codes that we have. And if you remember, the first code corresponds to masculine, the second code corresponds to feminine, and the third code corresponds to unknown. So you can see also that information. And this extra service is a data generator, so it's like the two services that we started with, but generates a JSON that is basically a canonical transformation from the XML to a JSON document. So this is not a canonical JSON format in the OpenEHR standard. Yeah, this format is accepted by the EHR server CDR. We will test in another video. So we will try to generate, for instance, a JSON composition. So this will be a JSON instance. We will not include versioning information. We will just generate the composition. And we can choose if we want participations or not. Participations is just a structure inside the composition that allows you to point to people that participated of the clinical process that this document is documenting. In this case, we don't have a clinical process because this is demographic information. Yeah, so we don't need to add participations. We will generate composition. We just click on that, and that retrieves the document. With this document, we can copy it, or we can access this document from the menu on this menu compositions. This is stored in your account. And this contains the composition. You can see this is defined by the root archetype composition demographics. That makes sense. And the template ID is demographics. That also makes sense. And you can see internally, we'll go to the content. We'll find an administrative entry there. And you can see here two elements. The first element is the sex. And here we have data. and this is generated automatically from the constraints defined in the template. So the generator just picks one of the options, masculine, feminine, or unknown, and retrieves that in the code. And for the date of birth, this just generates the current date. So this doesn't make any sense. Yeah, we could change this, for instance, to have a patient that is 25 years old. So we can change that later. But this is the data that we need to test. We will do the same process, go to templates, and we will upload the other operational template for the vital signs monitoring that was uploaded. Then here the server is working to index the internal structure, so you can see the trees here, the internal archetype nodes and the template nodes, and that information is required for these other services, the data generators, to work. Yep. So that is now indexed internally, and we'll go again to the canonical JSON instance generator. This is actually a clinical record, so vital signs monitoring is a clinical record. We could add participations. In this case, I won't add any. We don't need that for this example. Generate composition, and the same. We'll have the composition here. You can see first that the root archetype is the vital signs monitoring composition, that the template ID is vital signs monitoring. That information is on the template. And inside the content, you will find a list of observations. The first observation is the blood pressure, and inside you can find data related with the blood pressure. So let's search for instance, here in data. Here we have data for the systolic, and here we have data for the diastolic. If you check the values, they don't make sense clinically. So we could change those if we want, so our data in our server makes more sense. The toolkit doesn't have enough information to know that this is a blood pressure and to know this should be a lower value, or that the systolic should be higher than the diastolic. It doesn't have that information in the template. So we can edit that data later to make the data look more realistic. But for testing, this is not needed. We don't need to change any data here. You have here another observation that is body temperature. The same with the values. It might have a higher value than it should. We have heartbeat here, pulse, all the information is here, and oximetry and respiration. Yeah, everything is here. So let's go back and check the dependencies. For this one, we have the vital signs composition, and we have a reference from the composition to the blood pressure observation, to the body temperature observation, the pulse, heartbeat observation, pulse oximetry observation, and the respiration observation. Yeah, you remember we created this template in this way. And of course, because this has more archetypes inside and each archetype is more complex than the demographics one, you will have a lot of nodes, for instance, in the archetype node. And you can sort by archetype ID. And here you can see, for instance, all the compositions, the paths. These are similar to the previous ones for the demographic data, but for the blood pressure, you will have a lot of paths here. And you can see, for instance, here, there are translations for more than one language. This is because the archetype for the blood pressure might be available here in the archetype. If we go to the archetypes, blood pressure is here. That is why you see there are more translations. But these translations for Spanish, for German, are not in the template. So this is basically showing you what is in the template. This template is in English, so every English term here is from the template, but also is checking, do I have this archetype loaded in the archetype section? And can I extract this data from the archetype? Yes, so here it is showing you all the translations that are found in artifacts that you have loaded in the toolkit. And you can see here we have many paths. Yeah. The nice thing here is that you can search, for instance, by text, and you can find by the name of the node the corresponding archetype ID and path, and you can then check the type to see if that is the specific node that you want to retrieve from a query. We will use this information in the data queries to retrieve data. So right now we have two compositions, demographics and vital signs. Both are JSON, and these other compositions were created previously. These compositions have this size, and you can see the vital signs monitoring is way bigger because it's more complex. It's just that. So I will go to the demographics one. What I will do is copy this. I will prepare the requests to the post composition endpoint, and I will show you how everything works from the creation of the EHR. But first we will try to do this. So I have here already a request for the post composition service endpoint, and I will just duplicate this, commit composition. This will be vital signs monitor. No, this is the demographics one. Demographics. Demographics. And here in the JSON, you can see there is a composition that is JSON. So I will delete this and I will paste what I got from the toolkit. This was the demographics composition generated in the OpenEHR Toolkit. And I will change on this one a couple of data points. For instance, the date of birth. Let's make this guy older. So this will be, let's say, 40 years old, something like that. This is masculine, this is okay. Let's see other data that we might want to change. Here, for instance, we can change in the context the start time. So instead of having a fixed date here, the start time represents the start of the recording of the information here in the content. So we can use this tool. This is Insomnia REST client. I will show you a link to this later, and this request will be available for you. So here we can use the date generator. So this will generate a new date every time this composition is committed to the server. So when each request is done. And I don't think we need to modify anything else. And the endpoint here is just all of this is the base URL for the API of the EHRBASE. EHRBASE REST OpenEHR v1 is the base URL. And from here, this is part of the OpenEHR REST API. So we have an EHR. This is the ID of the EHR. I will show you that in a second from where we get that ID, because we didn't create any EHR yet, and then / composition. We will do the same for the other composition. I will duplicate this, and this will be the vital signs monitoring JSON. This is here. I will delete the contents. I will go back to the toolkit. I will grab this composition. Here I will copy, and I will paste that JSON here. And this, you can see, for instance, here all the text nodes are just random garbage, just auto-generated. We can say, for instance, on this one, the start date, we can also add our generator. So I will say this will be a date that will be generated every time this request is executed. Then we have the blood pressure. And to make this more clinically realistic, I will search for the systolic blood pressure. We have here. So systolic, a normal value should go between 90 and 150, something like that. So I will erase this, and I will use a plugin that is the random number of the Insomnia REST client, and you just click on that, and it will allow you to generate a random number between a limit. So this will be 90, let's say, and 150. And each time this request is sent to the server, this number will change. And for the diastolic, I will do the same. So let's change that. So random number, click on that. This will vary from, let's say, 60 and 90. Yeah, this should be lower than the systolic. And you can do this for all the data points that relate to numbers, for instance. The same to the dates. You can change the dates using the datetime generator. Or you can change, for instance, some identifiers. Yeah, like this one, that is the identifier of the composer of this composition. So if you want a different composer on each submit to the server, you might want to generate this UUID, and Insomnia has a UUID generator. We can also, because the internal observations, you can see all the observation entries, they have a history structure, and you can search for history. And inside the history, you can see an origin value. Because the history is a time series structure, is the moment when your events that you record in that time series start. To make this more realistic, you can also change these dates of origin to start when the request is sent. So I will use the same generator here. So I can do the same for all the history points. And inside the event, you will find one event, and the event has a time. You can do the same with the event time. First, I can do this for all the history structures. Start is here, blah, blah. And you need to do this one time. It's not that each time you send a request, you need to do this. This is for each composition that you create. And that's it. Then when you send new compositions to the server, this data will be dynamic, will be different for each request that you execute. So that is very nice that the Insomnia REST client provides something like that. And then your data will look more realistic. And when you query that data, will look better. It is not possible for the OpenEHR Toolkit to generate dynamic data. So this adjustment needs to happen after you generate that. I have a couple more of these histories. Another ISO there. One more, and that's it. Yeah, so we will play with this. Yeah, everything is there, changed. Yeah. Here for the temperature, the same, we can change the values. When we find this code is because there is no constraint defined in the template, so the generator can't know which value to put on this node. So this you might find for some of the data generated. But that's no problem, we are just testing this. So these are the requests prepared to generate data on EHRs. First, we need to upload the OPTs on the EHR. I will double check that the server is running. This is an endpoint specific for the EHRBASE, just to get the server status. So it's EHRBASE REST status. So we will try to upload the OPTs. I already have here a couple of requests to upload OPTs, but those are not our OPTs. So our operational templates will use these endpoints. So it's definition/template/ADL 1.4, and the rest is the base URL for the EHRBASE. So I will copy this one, and this will be our demographics. And here I will delete that one, and I will go in the toolkit. I can take a look at the internals of the template here. I can go here and just select. I can also open the file and just copy from the file. Yeah, that's our operational template for the demographics. Here you can see in the basic authorization, this is the authorization tab for the Insomnia REST client. And here I used the basic auth and the standard user. That is found here. If you go to the EHR-based files that you downloaded, that information is on the page I showed you before. You can see that the environment variables have this security auth user and security auth password, and those are the ones that I use directly. I just copy and paste here. Yeah, you can see that is basic authorization. Yeah, So I didn't do any configuration on the server. Yeah, I just downloaded the files that the documentation said how to download and where to locate those files. And I just put these fields here, this data here. And this should create the OPT in the server. I just sent a request to EHRBASE and I got 204 no content. That means that the request was processed by the server and that my template was stored in the server. So here you might find some kind of log here in the terminal. We can double check using the list OPTs endpoint. You can see here is just a get to /definition/template/ADL 1.4. You can check there that demographics is there. Yeah, this is just basic information about the templates in the server. We will do the same for the vital signs monitoring. So I will just clone this one and this will be vital signs monitoring. My typing today is very difficult because I'm freezing currently. It's winter here. I'm in Uruguay, so my typing is not the best today. Let's open the OPT and copy the OPT from here. Yeah, this is the vital signs monitoring OPT that I created on the previous video. I will copy this and I will put this here. That should be valid, and I will send that to the server. 204, that's okay, and let's list the OPTs there. Vital signs monitoring is there. Small success here. Now we have all the requests already in place. We have the operational templates in the server. Let's create some EHRs and let's add clinical documents to the EHRs and the demographic document. So we have one clinical document and one demographic document. So the create EHR endpoint is this /EHR, just that from the base URL. And you can add a body to the request. The body is actually the EHR status. EHR status, you can see the structure here, the specification of the EHR information model of OpenEHR. And you can see on this diagram that you have EHRs here, all the attributes, and you have an EHR status here. The EHR has an EHR status, is associated with an EHR status through this link to a versioned EHR status. This is just a container of different versions of the EHR status. The EHR status, the main role of that is to contain a reference to the patient. Yeah, that will be in this subject attribute. You could create versions of this because in different points in time, this could change. Maybe not the patient itself or the reference to the patient itself, but some data in the EHR status could change. For instance, you have these other details that is a generic structure, and inside that you can put anything, virtually anything, and that could change in time. The EHR has a version of that contains many versions, and each instance of EHR status on different times will be a version, and the one that will be active at the current point in time is the last version. So when we create an EHR, we can provide the first version of the EHR status. And that is the structure that we will provide. And the way I will provide that is using the serialization format of the EHR status in JSON. And that is defined by the OpenEHR specifications. There is a schema for the JSON format of the EHR status. You can see here, this is the EHR status, the JSON format. And you can see this has a name, has a reference to the subject, and the subject is the attribute that is here. And the name is inherited from locatable, this name attribute. And inside here, you have a reference in this ID attribute to an ID of the patient. This is not a real ID, it's an internal reference to the patient. It's an internal identifier. It's not something that is the national ID card, it's not the social security number, it's nothing that can actually identify the patient in the real world. It's something internal to the platform, to the clinical repository platform. So here you can see that I already created a random UUID. This means that each time I send a post to /EHR, this identifier will be different. And I want that because I want to be able to create many EHRs And if you send the same request with the same subject ID value to the server, the second time you send that same ID, it will give you an error because you can create just one EHR for each patient. So you can't reuse these identifiers. That is why I created this. This is an insomnia feature to create random data. And also you can create the identifier of the EHR status, or you can let the server assign one identifier. And this UID is also inherited from the locatable class, this one here. Yeah, and is modifiable and is queryable are also attributes here. So this example doesn't have the other details structure. Yeah, this one. So other things to take a look here, basic authentication here. This is what I want the server to return. I want to return the full representation if the server creates the EHR with this EHR status that I provided. This is part of the OpenEHR REST API specification. It's a header that you can use. And also I'm saying here that I'm sending JSON. You can also send XML here, and you can follow the XML format for the EHR status, and that is also defined in the OpenEHR specifications. For the OPTs, we don't have a JSON format for the operational templates yet. So in the next future we will have. So everything could be just JSON. So if I send this is the response of a previous test that I did. It's not from now. But if I send something right now, yeah, we can see that the returned object is an EHR, and the EHR contains a system ID, an EHR ID, and a EHR status. As I said, the EHR status in the server will be a list of versions. So this one that is returned here is just the latest version. And since this is a new EHR, the latest version of the EHR status is the first version of the EHR status. And this should be the one that I provided in the post. And the time created is actually the time the EHR was created. And this should be right now. So that worked. And we don't have in the OpenEHR REST API a service to actually list all the EHRs in the database. So that's kind of a limitation, I would say. So we might need to take note of this ID if we want to use that ID in the future. We will keep that response here. We already uploaded the OPTs, so we can send data. What happens if you want to send data to the server, compositions to the server, and the OPT is not there? The server will return an error because the server, the EHRBASE server, is using the OPT to validate the data that we send in compositions. We created the OPTs first, so if we want to go to the post composition or commit composition endpoint here, and we choose these demographics and vital signs monitoring, we can actually send that to the EHR we just created. How we do that? If you see here /EHR /something here /composition, that something will be the ID of the EHR we just created. And if you see the response from the server, the EHR we just created has an ID that is 998BC something. And if we go to the post composition and we mouse over here, this should be 998BC whatever. Yeah. How is that? Because this box, if I click on that, is a reference to the response of a request. The request is the post to create the EHR, and the value, since the response is a JSON, we can use JSON path to navigate that JSON and get the specific data point from that response. That is why we have here the ID of the EHR we just created. We can use that value in the URL, and this is part of the OpenEHR REST API. So this one will send this composition to this EHR. Let's click on send, and let's see if this works, or if we get an error. We got the full composition and 201 created. We got the full composition because, again, in the headers, we added here the prefer return representation. If we remove this or we choose to return minimal, we might get a different result. So return representation is the full resource that was created in the server. And this resource is the exact composition that we just committed. And for this one, we don't need to send many of these because they will contain always the same information. It's the date of birth of the patient and the sex at the point the patient was born, the administrative sex. So we don't need to send more than one. And we will try to do the same, and this could be more complex, for the vital signs monitoring. The URL is the same, the variable that I just mentioned about the EHRD is the same, and the only difference is the composition itself. So we'll try to send this, and maybe we get an error. This is passing, so we didn't get an error for validation. We got the same here, the same composition that we sent here. And you can see, for instance, in the context, the value that was a variable there, you can see here is the current point in time. This is my local time in UTC, but I'm 3 hours before UTC. And for this one, since also for the blood pressure, we can search for instance, systolic. Yeah, we can search systolic here, and you can see these values make sense and are clinically realistic. If I send again and again several compositions, you will see these values will change, but will change in the range that I set for those values. So I can send more than one to the same EHR. Let's send another one, let's send 5. 5 will be enough. So that's it, let's send one more, just in case, to be sure. So right now, in the EHR, we have, in the EHR we just created, we have one composition for the demographic data, and we have 5, 6 compositions for the vital signs. For the compositions, we can actually get them. We can get them by ID. So here in the URL, I can put the ID of those compositions. We can see what we can do using the reference documentation, because the EHRBASE implements the OpenEHR REST API. So this should be a good reference of what you can do with the EHRBASE API. So let's search here for EHR composition. So we can, for instance, get composition by version ID. We can get composition at time, because compositions could also be versioned, and at different times you can have different versions active for the same composition. So we can say, at this point in the past, what was the active composition at that point in time? So we will use the get composition by UID endpoint. And for that, if you see the response, for instance, for the demographics, we will have the composition, and we will have a UID somewhere here. So we need to find that UID is here at the bottom. And this UID was assigned by the server. So we need to go to the composition, UID value to get this value. We will do that. So we'll use the get composition, is the base URL, EHR. Then here we need to put the EHR ID in the URL. So we will do response, body attribute. Here in red is because this is not configured yet. So we'll click on that. Which request? We need the EHR. So the EHR, we have the information from the EHR we created. So we go to the post EHR, and then inside the EHR we go to the response, is the $. Then here we have EHR ID, is the container for the ID, EHR ID, and the value is the UUID. So done. And then, because we want to get one composition from that EHR, here we need to add the composition ID, the composition we just created. So we need another response attribute, body attribute. Again, we have this in red. We need to click on this to configure that. For the request is the post composition demographics. We will try to do that one. $, then UID, then value. That's the identifier for the composition. And you can see that it contains a UUID, a namespace in the middle. This is the system ID. And this is the version number for this composition. Since it was just created, version is 1. Yeah. So that should work to get the composition from that EHR, and that is the demographics composition information there. So that works. Now we want to retrieve data. So this retrieves one document at a time. What happens if we want to check, let's see all the EHRs that we have in the database? We don't have an endpoint for that, but we can use the query mechanism from OpenEHR, the AQL, the archetype query language, to do that. So let's say we want to get all the EHRs from the server, the EHRs that were created, the one that we created and the ones that might already exist in the server. So we will clone one of the requests that we have for testing queries already, because I was working on testing EHRBASE for conformance with the OpenEHR specifications. We have here a sample for the query. We will clone that. Let's clone that, and this will query EHRs. Let's put that name and let's move that up to our test requests. So I will put that here at the bottom. Yeah. So here we need to write the queries manually. There are some tools that allow you to create the queries by selecting parts of archetypes and templates. We won't use those tools. We will just write by hand. So hopefully this will work. Let's say we want EHR ID value from all EHRs. Yeah, we can just write this as, and that's it. The auth should be configured, so basic auth. Here we will just copy the user. We will also copy the super secret password. That's okay. I don't think we need that header, and let's check this. Here we just retrieved all the EHRs that exist in our database. What happens if I create another EHR? Let's create another EHR. Let's execute this query again. And that's it. We can also here ask for the EHR created date. So this time created value, we can obtain those. So this is time created value. So here we retrieve all the EHRs, all their IDs, plus the date those EHRs were created. Yeah, pretty simple. Now, let's say for the EHR that was my EHR, the 998BC, blah, 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 is the one that has some data in it. So we can do stuff like this. Let's get compositions in EHRs. So let's say I want the EHR ID plus the composition UID value. And I will say from EHR contains composition C. And you can see here different compositions in the same EHR. The EHR is repeated. Here is the same EHR ID. And this is the ID of the composition. The first one will be the ID of the demographics composition, and the rest will be the compositions that I created for the vital signs monitoring. What happens if I want to know which template was used for each composition? So I can check the structure here of the composition, and you can see that in the archetype details template ID value, there is the name or the ID of the template. Yeah, so I can use something like this. I will copy that. I also want the ID, but I want also the composition / archetype details / template id/value. Let's see if this works. And you can see here we have 1, 2, 3, 4, 5, 6 vital signs monitoring documents, and we have a demographics document there. So this is working. This is working very well. What else can we do? Let's say we want information from the composition. And for this, we will use archetype nodes here. So in the demographics template, we have some, let's sort this by path. We have some paths, for instance, this one that points to the sex and this one points to the date of birth. So we can do something like this. I want from this archetype, this path. So we can do something like that. So we will do clone this. This will be get data from compositions. These are different types of queries that you can do. So let's say we still want the EHR ID, we still want the composition ID, we still want the template ID, but we also want some data from these compositions. So this is not constraining. You can see here the EHR that we are querying. We are querying all EHRs, and this will get information from all the EHRs that have some composition. Inside the composition, we want to query admin entries. So we will query compositions that contains admin entry. Here we use only names of classes of the EHR model, and this should comply with this archetype ID. I will need to check this from memory. I might be doing some mistakes here, but let's try to do this. And this will have the alias A. Yeah. And let's say we want from the admin entry this path. And I will return that in the projection. In the projection is the select attributes. So that will be A slash, and this is the path. Double slash, let's delete that. Again, this is querying all the EHRs. And this is doesn't have the A. I need to double check this works. Maybe I made a mistake here. Let's check without all the other projections. No. This might be contains admin entry. This might be an issue with this one. Let's go to the reference. When you have an issue, you go to the specifications. Always specifications. We want the query language. We want to here query language AQL here, and we will go to the examples. There are many examples here. I actually worked on improving the specification, so it seems I don't remember. The A should go before this constraint. So the syntax is this way. Let's see if that works. Small mistake. Sorry about that. What we have here, we have the result is one EHR, one composition. That composition is the one that contains this data point. And this data point, you can see that is a coded text. It returns the full data point. Yeah, this is the data type from the OpenEHR model. It's not just, you know, the masculine or just the code. It's the full structured data point. Yeah, this is a data value in the OpenEHR model. And you can see here you have the type, you have the name associated, then you have the code, and the code contains the specific code and the terminology ID. The terminology ID is local because this code is defined in the archetype. When the codes are defined in the archetype, the terminology is always local. Yeah. If this code would be, I don't know, maybe a SNOMED code or something like that, an ICD-10 code, whatever, you will see here SNOMED CT, ICD-10, etc., whatever, in the terminology ID value. So that works. What happens if you remember I created another EHR? So this is another EHR. If I send to the server another composition for the demographics, I can, this is creating the demographics in the other EHR. This is AB2 blah blah blah. If I execute this again, you will get another result because I just created another demographic entry for the demographic composition in the other EHR. So the other EHR is AB2 blah blah blah. So we are actually getting information that we created from the compositions. Also, let's add some variation. You remember that masculine was code AT0003 and feminine was code AT0004. So let's modify that by hand. So we will create another EHR. Let's create demographic information, but changing the sex. So I will go here. This will be fem with uppercase, feminine, and this will be 004. And I can also change the date of birth. So let's say this is later. Yeah, from later. So let's send that to the EHR I just created. So we have 3 EHRs now, 2 with masculine sex and the last one with feminine sex. If I execute the last query again, we are just getting data. Yeah, you can see masculine from the other EHR, and from the new EHR that I just created, you can see feminine here. So what happens if you want just data from, let's say, feminine EHRs? Feminine EHRs is not a real thing, but you understand me. EHRs that have a feminine patient. So let's get this here from compositions with condition. So let's put a condition in the where. So we can have the EHR, the clinical document ID, this is not a clinical document again, it's just a record. It's demographic record. We have the template ID, we have the specific data point for the sex, but we can have like where a slash blah blah blah. This will use the same reference to the sex node, but now I want to access inside that data point. So if you see the data point, this is the sex, but I want to go into the definition code, into the code string, and that value. So this will be definition code, the slash value is the coded text, definition code, code string equals 2, and this will be AT0004, and that will be only the feminine results. Let's see if this works. Yeah, it works. So I got just the results for feminine. So that makes sense. And what happens if we want to query the clinical data? Yeah, the vital signs monitoring data. So we can get, for instance, the data, just the plain data. So we'll clone this. This will be vital signs there to differentiate from the demographics one. Yeah, let's put that at the bottom. So here I want compositions, and I will constrain the compositions by the archetype ID of the compositions. And this will be, what's the archetype ID for those compositions? Let's go back to the templates, vital signs monitoring, and I will go to dependencies, and I can say, this is the root for that one. So I can use that here. I want to get EHRs and compositions in which the composition is defined by this archetype. And again, I have an issue here. Composition C. This one. I didn't remove the path. This one. Now this should work. It's difficult. It's difficult. You need to be patient. So here we got the ID of the EHR. Again, we are querying all the EHRs here, not just this one, the 998BC. So here we got information about the EHR, the composition, and only the ones that are constrained by this archetype, the composition vital signs archetype. We can also constrain by the value of the template ID. We could do that. We can just add where C slash archetype slash template ID slash value equals vital signs monitoring. We could do that. and we will get the same results for the data that we loaded into the server. Let's get some data for this. So let's say I want, this is not getting actual data, this is getting just the composition. This is get compos. This is get compos in EHR for the vital signs. Now let's get some data. So let's clone this, get vital signs data from compos in all EHRs. That should be the correct name, because we are not constraining the EHR, the specific EHR. We could actually constrain the EHR by ID, and we can only query one EHR. Let's say we are doing population queries, just for playing around with this. So we want data. Which data? We can have here temperature data, blood pressure data, oximetry data, the pulse, etc. So we can go to the, again, toolkit. Let's here go to archetype nodes, and we will sort by archetype ID, and we will go down here. For instance, we will start with blood pressure. We need to search for diastolic, for instance, and we can search here for diastolic. So here we have diastolic. This is the route for the diastolic, and we need then the route for the systolic. So we will get data from an observation that will have this archetype ID. So this will call composition contains observation. This will be O1 that complies with this archetype. So we will get data from this observation O1, that is the blood pressure. So in the projection we'll put O1 slash, and we will copy this path. This is the path to the diastolic value. Let's execute this. Again, we have an error somewhere. Contains observation. Here we have a double slash. Let's check again. Simple errors. Be patient. This is difficult. Here, what we have? EHR ID, composition ID, template ID, and the systolic value. And you can see at different points in time, in different compositions, the systolic value is different. This is because we use the random number generator from Insomnia REST client. This is nice. Let's check if we can get the systolic. So let's search systolic. Is this path. This is the systolic node, dB quantity. I know this is the systolic because this is a physical quantity, and because of the name here, systolic. And this is another path that we will use. So we will get this from the same observation. So this will be O1 also. So we'll add here O1 slash blah 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 0004 slash value. And this needs a comma here, and 005 is diastolic. So 4 is systolic, 5 is diastolic. We can send this. Hopefully this works, and we can see systolic, diastolic, systolic, diastolic from the same composition, from the same observation. This is the same to get information from the other observations. Let's do one more, just to show you how you can get more information. So we have temperature here, and we need to find the dB quantity inside the temperature observation. So we will here, we need to add the composition contains this and the other observation. And for the and, I need to go to the reference because I don't remember by memory. Need to get from two alternative observations inside the same composition. So if I search for and, this will search forever. So let's try to find an example. Remembering the syntax is difficult, by memory. And it's really an or, I think, instead of an and in this case. So let's search for contains observation. I need one that contains two observations. This is EHR contains composition and composition blah blah. So I can use the OR. This is the one, the OR notation. So here is contains parentheses, this observation, or observation O2 that complies with this other archetype. And O2, you can add that to the projection. We want to use the path to the temperature, this one, slash blah blah blah, and that is the temperature. Again, I need to close the parentheses. So here you can see we got blood pressure, systolic and diastolic, and the temperature. We don't have units because the constraint was not specified in the template. So that's something that we can fix in the template, and then we can generate the data that complies with that template. But also to get information from the heart rate, respiration rate, oximetry is the same. It's just archetype IDs and paths. And another thing that we can do here, and we will use this example, and this will be our last example, is with condition. So we can get, for instance, this data, but when the blood pressure is high. So we can get, this is the systolic, and this will be magnitude. The value is a dB quantity, and the dB quantity has an attribute that is magnitude, and this is the numeric magnitude of the blood pressure, the systolic blood pressure. And this should be, let's say, bigger than 140. And let's see if this works. So if we get data, we get data only for compositions that contain an observation for blood pressure where the systolic value is higher than 140. 145, 148. Yeah, so that works. And we can say we want that to be higher than 140, or for instance, this higher than 70, 80, or whatever. So we can add another condition here. And we can do the same for any value that we have in the entries. So it could be high temperature or low temperature, or high respiration rate or low respiration rate, or a respiration rate in a range of values. We can query using that. The query language is pretty generic. So that is the full cycle. We created archetypes. We created templates. We exported the operational templates. We created data, random data based on the operational templates. We uploaded the operational templates to one server, in this case, the EHRBASE server. We created some EHRs. We created some compositions, and then we queried those compositions in different ways. Yeah, we queried EHRs, we queried compositions, we queried internal data, and then we filtered the compositions and the data by certain values, like this case. So these are things that you can do with an OpenEHR clinical data repository. Some CDRs have different ways of working with the querying mechanism, for instance. We'll see another querying mechanism, but the rest is very similar, and the flow steps are the same for every single OpenEHR CDR out there. And everything is standardized. Everything is following the OpenEHR specifications, the OpenEHR standard, the information model. All the data here follows the information model. The API is based on the OpenEHR REST API. The data validation is considering the operational template constraints, and the query mechanism allows you to query anything in the EHR. So it's pretty simple if you know what to do. If you don't know what to do, you can ask people that knows how to work with this. Always the best advice is read the specifications. We have a lot of specifications here, and the OpenEHR community has also a discourse site where you can ask questions. Me personally, I like to answer questions here and discuss. So if you have any questions, just drop a line here. You have a lot of people that knows a lot about working with the standard and working with EHRBASE here available to you. So use that resource. All the resources that we use on this presentation, this tutorial, will be available online on the links on the description. Yeah, so you will have everything to test yourself against EHRBASE in this case. Next time we will see EHR server, we will see EHRscape, and we will see Atomic server. Yeah, hopefully this helps you. If you have any questions, just let me know, drop me a line. You know how to find me. Bye bye.